About the topic preservatives as cosmetic excipients. We already discussed about cosmetic excipients, surfactants, emollients. Next topic is preservatives. What is the importance of preservatives in cosmetics? Why we are studying preservatives in as a cosmetic excipient? Why we are adding preservatives in pharmacological products? To prevent the deterioration of product, and to maintain the stability of the preparation. When the stability is important? During the shelf life of the product. So coming to the cosmetics, we will have around a shelf life of from 1 year to 5 years. Can be 5 years. So we need a long time of shelf life for cosmetic products. So in order to maintain the product stability during the shelf life, we will be adding preservatives. Okay. So the preservatives, what are the ideal properties of preservatives? Before that, we can go to a small definition of preservatives. What is preservatives? Preservatives are substances added to pharmaceutical dosage forms and cosmetic products to prevent the microbial growth and ensure product safety and stability. So preservatives can be added to pharmaceutical products as well as cosmetic products. And what is the main aim of adding preservatives? To prevent the growth of microorganism and maintain the stability so that we can ensure the safety of the product. Coming to the ideal properties of preservatives. What is the ideal properties that a preservative should have in order to add it in a cosmetic excipient? Should be non-irritant. We will be applying the cosmetic products to the human body, hair, skin or oral cavity. So it should be non-irritant to the wherever the area we are applying the cosmetic products. Should be non-toxic. Should not cause any toxic reaction in the body. Physically and chemically stable. Physically and chemically stable means the preservative should not undergo any type of physical or chemical reaction like oxidation, hydrolysis or reaction with sunlight. So this it should be stable with in the environment, compatible with other ingredients used in formulation. The main aim of adding the preservative is that to prevent the microbial growth and maintain the stability. So it should not interact with other ingredients used in the formulation. Should act as good antimicrobial agent with a broad spectrum of activity. The main aim is the antimicrobial activity and it should have broad spectrum of activity. What do you mean by broad spectrum of activity? The preservative should be effective against a broad number of microorganisms. Its activity should not limit to any specific one type of organism or any one category. It should be active against both gram-positive and gram-negative bacteria. So broad spectrum of activity is required. Effective in small concentration. We are adding preservative as a cosmetic excipient. So it should have its antimicrobial activity at the lowest concentration possible. We can only add very small quantity of preservative. So it should be potent. Potent means it should be effective at a very low concentration. Next, should maintain activity throughout product manufacturing, shelf life and usage. So the antimicrobial activity or the preservative efficacy should be maintained from starting of manufacturing till to the usage by the customer. So the preservative activity should be maintained throughout this period. These are the ideal properties of preservatives. Coming to simple classification of preservatives, first one based on mechanism of action, how the preservative exhibit or how the preservative exert the action. First one, antioxidants. Antioxidant, what will be the function of antioxidants? They will be preventing the oxidation of pharmaceutical ingredients or excipients. Example, Vitamin E, vitamin C, they are natural antioxidants. Next, antimicrobial agents. Example, sodium benzoate, different types of benzoate esters, sorbates can be used as antimicrobial agent. Next, chelating agent. Example, citric acid and polyphosphates. What do you mean by chelating agents? They will form complex with, if any metallic ion is present in the formulation as an impurity, it can cause this metal. What is the main reaction of metal? Metal can react, it's a very reactive substance, so can react with a wide range of product substances used in the formulation. So what will be the chelating agents doing? They will complex with these impurity metal ions and remove them. Okay, these are the classification of preservative based on the mechanism of action. Next, another classification based on the source, that is natural preservatives and artificial preservatives. Natural preservatives, you are familiar with the natural preservatives that we can use in the home. Salt, honey, neem oil, lemon. These are used as natural preservatives. An example for artificial preservatives, benzoates, sodium benzoate, sorbates and propionates. Okay. Next we will go with some classes of preservatives that can be used as cosmetic excipients. The most commonly used classes of preservatives in cosmetics. First one, organic acids. Different types of organic acids can be used as cosmetic excipients as preservative, and their activity will depend upon the carbon chain length of the organic acid. So in organic acid, number of carbon atom is an important factor in the efficacy to act as a preservative. So if the alkyl chain is around 6 carbon atom, it will have more activity as a preservative. When alkyl chain length is high, solubility decreases as the chain length increases. When the carbon chain length increases, what happens? The antimicrobial activity can increase up to a limit, but with increase in number of alkyl chain length, solubility of the organic acids decreases. Effectiveness depends upon pH and concentration of undissociated acids. We know the acids can exist in two forms, dissociated form and undissociated form. We will be preferring undissociated form. Why? Undissociated forms can easily cross the human cell. But here what we require is the antimicrobial activity. And the antimicrobial activity is more at dissociated form. Dissociated form exhibit more antimicrobial activity, and this further depends on the pH. Whether the pH is acidic or alkaline. In organic acid will be undissociated in acidic pH. Right? Organic acids will be dissociated form in alkaline pH. So we will be favoring the dissociated form, because the dissociated form will be more antimicrobial activity. So in order to maintain the pH, we have to maintain the pH of formulation to exert the antimicrobial activity. And some examples of organic acids used as preservatives: benzoic acid, propionic acid, salicylic acid. Second one, alcohols and phenols. What is the importance of alcohols and phenols? Alcohols and phenols can be used as the preservatives. And coming to the phenols, what is the structure of phenol? Structure of phenol. Structure of phenol? A benzene ring with the OH group. So this phenol, if we are substituting this phenol with the carbon alkyl chains, then the number of alkyl chains depends upon the activity of phenol. If the number of alkyl chains increases, antimicrobial activity also increases. And we are having halogen group, we are adding chlorine. Halogen group at the para substitution of phenol, then antimicrobial activity increases. And we are adding halogenated phenol with the ortho substitution of any alkyl group, then also antimicrobial activity increases. So the QSAR of phenol is important in the determination of antimicrobial activity. I can repeat once more. The phenols will have antimicrobial activity, and their activity can increase with the substitution of alkyl chain at para position. And also we are replacing the para position of the alkyl chain with the halogen group, their antimicrobial activity increases. And this halogen group is at para position and alkyl chain group at ortho position, then also the activity can increase. Okay. An example for the alcohols and phenols coming under this preservatives, paraben. You are familiar with the parabens, methyl paraben, propyl paraben, triclosan, chlorobutanol, orthophenyl phenol, chlorocresol, chloroxylenol. Chlorocresol, what is the structure of chlorocresol? Para position chlorine group and ortho position CH3 group. Chloroxylenol, benzyl alcohol, phenoxyethanol and phenoxypropanol. These are the examples